Today's scanners can magically transform real objects into point clouds or meshes to your computer. You can now easily reproduce a physical product and even print it in 3D. This process is so common, it has been considered a commodity for years. But there remain three challenges which continue to slow down engineers when working with scanned data. The first, transforming the scanned mesh into a manufacturable model, takes a long time to achieve the right level of quality. Next, tooling compensation for part deformation, such as springback, introduced by the manufacturing process, is a complex manual activity requiring many iterations. Lastly, reconstructing a real, usable CAD model from the output results of shape optimization software is a very time-consuming job, often requiring weeks of manual effort. Today, we're going to show you how CATIA's specialized scan to 3D print applications are addressing these challenges, removing delays and transforming the process. You'll see how to drastically decrease geometry reconstruction time. Users are reporting time savings of 30 to 80%. How automating tooling compensation means what used to take days can now be done in a morning. Cases have shown that time can be cut from a week to a half a day. And how we change the game in CAD reconstruction for optimized topology by doing in days what previously took weeks. CATIA brings a powerful set of integrated capabilities which remove these delays and transforms the process. This means faster engineering that's right the first time, with greater efficiency and higher quality. Let's look at each of these processes in detail. First, how to quickly and easily transform a scan into a ready-to-be manufactured part. It's important that the user has full control of the reconstruction strategy and the quality of the result. Also, it's important to avoid the delay of conversion by creating a CATIA model directly. The major benefit is a huge reduction in the time needed to accomplish the reconstruction task. For example, a typical automotive body reconstruction from scan to surfaces can be reduced from 20 hours to 4. A part scan into a solid model with editable features can be reduced from 8 hours to 1. In both cases, that's an 80% reduction in time, leading to incredible savings. Even more impressive is a scan to one surface reconstruction that could take days. This can be done in about a minute. In this example of a trim steel die component, the shape is defined by a cloud of points. You'll see how CATIA combines surface design and solid design to recreate an exact model very rapidly. We'll start by enclosing the surface model into a solid body. We can then split the body into the main surfaces of the part. We can easily extract surfaces to start our trim using CATIA's Quick Surface Reconstruction Workbench, also known as QSR. Here, the outline of the bottom is created as a horizontal planar section and can be used to create a sketch. For better quality of the sketch, you can create a curvature analysis map showing the main curvature changes. Using cutting points, you then select the type of sketch elements you want in between, or simply let CATIA automatically choose the elements for you to create a standard sketch. This can then be extruded as a splitting element to create the right shape. You can use the same process for additional splitting operations. For complex surfaces, QSR has tools to reconstruct them by quickly approximating the shape with a brush-like tool or flood selection. The surface does not need to be perfect. Then, using an automatic surface tool in QSR, the resulting unlimited surface is created and is usable as a splitting tool in the part design workbench. After the main surfaces are created, you can use the usual tools of part design for the remaining operations. Easily create missing fillets and add features like holes and pockets. In this example, the whole procedure from import of the points to the final fillets on the body takes less than 30 minutes for a trained user, and is a very efficient part recreation methodology. In this next short demo, you'll see how quick and easy it is to transform a scan into a ready-to-be-manufactured part. Here we can start with the raw scan of a human hand. First, we'll use our mesh smoothing tool to have a slightly smoother mesh. Next, we can switch to this quick surface reconstruction workbench. With only one simple command, we can click on a point cloud, and in real time, you can see the resulting high-quality surface in CATIA, saving you an extraordinary amount of manual reconstruction time. You can now continue modeling additional detail or directly print to a 3D printer. Here you see the result of the actual printed 3D models. This process is extremely fast and easy, saving you time and money. As you know, all manufacturing processes generate deformations on the part. These can be due to springback of the sheet metal parts after stamping, warpage and shrinking of plastic parts after injection molding, or warpage of composite parts after curing, and many more. To address these phenomena, it's necessary to modify the geometry of the tooling to make sure the part is correct when it comes off the tool. For most people today, this is a very manual process that greatly increases the tooling design time, often doubling it. Some finite element analysis software can predict these deformations, or a first trial part can be scanned. But the challenge is how to use this mesh data to create quality manufacturing surfaces. CATIA provides a specialized application to morph the actual required tooling geometry from the results of the FEA prediction or a physical scan. The compensation is done fully automatically. This reduces the tryout phase from weeks to less than a day. It ensures high-quality results, eliminating or minimizing the manual finishing and tuning. Users have seen this approach reduce overall tooling costs by 50%. So now we're going to look at an example of how easy it is to create the tooling compensation for the sheet metal stamping of a car door based on finite element analysis for results for springback prediction. We begin with the model of the door. Clearly, if the tooling surface was geometrically identical to the part surface, the resultant production would be incorrect due to springback of the finished part. So we need to modify the tooling geometry based on a prediction of the level of springback. So we start with the car door geometry. We select the file coming from the FEA tool. It could be Abacus, it could be PamStamp, it could be Autoform. We select the part, and you can see there are over 130,000 points. This is the text file, which is the output from the FEA software. And here in red, we can display those points and their associated vectors, which show the degree of springback showing the displacement of every single point. As we want to create the tooling compensation surface, we apply a scale of -1 to counter-deform the tool, which is necessary to ensure the correct part. We can display a preview, so you can see here in blue the difference between the original and the compensated geometry. And again, we apply a scaling of -1 and recompute for a completely new surface, in red. This is the compensated tooling surface. This is a very effective and fast process. We have many customers today using this in production, not only for sheet metal, but also for plastic parts, composite parts, forging parts, and many other processes. When designing a product, there's always a trade-off between performance requirements for strength and stiffness versus size and weight. Recently, tools have become available to help in optimizing a part's topology, like Simulia Tusca, for example. The result is a very organic shape, which can be produced using 3D printing. There would be no chance with conventional manufacturing methods. but today it can take a minimum of a few days to several weeks to reconstruct the CAD model from the result of topology optimization. CATIA offers multiple applications to accelerate this job, and one of them, CATIA Imagine and Shape, is particularly efficient and dramatically reduces the reconstruction time. This example was done in half a day versus 5 days with traditional CAD tools. Another customer example showed a reduction from 7 weeks to 2 days. On average, the process is 10 times faster. In this demo, you'll see how we can quickly create an actual part based on a part-optimized mesh from Tosca. Using CATIA Imagine and Shape, we can use this geometry as a template or reference. Since it's symmetrical, we only need to recreate half. We'll start with a basic cylinder that approximates the diameter of one of the branches and quickly position it in place. Using the intuitive extrude and rotate face commands, we can quickly start to roughen the shape of the branch. Next, we can do the same for another branch. Once it's created, the branches need to be joined. We can use the powerful merge tool to create a smooth connection between the two boundaries, which can be easily adjusted to get the desired results. All the branches can be created using the same method based on the use of a very limited set of Imagine and Shape commands, mainly extrude, merge, and direct 3D manipulations. Then, Imagine and Shape allows you to mirror the other half of the symmetric part. The base plate of the part can be created using the classic mechanical CATIA tools or also by Imagine and Shape. In this case, it's been created with a mix of both technologies. First, the shape was created using Imagine and Shape, and then it's completed with the standard part design tools, mainly trimming and filleting. Another very powerful feature is the fact that this is still very easy to modify based on validation and finite element analysis recommendations. Now let's take a quick look at what some of our customers are saying. Ecker Design is Scandinavia's leading provider of turnkey mechanical and industrial design services. The new Hydrolift C27 was designed and constructed in CATIA. The development process begins by building a scale model by hand and then scanning the surfaces. Engineers then start to transform the scan into a ready-to-be-manufactured part with Class A surfaces. CATIA is then used to model all the standard parts and to design the custom parts in fiberglass and stainless steel. By modeling the entire product in CATIA, the design team had full control as they sought to obtain a design that would yield the best performance. Ecker values the, quote, high quality and stable export files which all our suppliers are able to read since they are devoid of any geometrical problems or surface defects. We now have a complete 3D system for designing a high-quality Class A surfaces and construction class surfaces, explains Victor Rosenbringe. Tooling Design Solutions is a leading South African company and deploys Dassault Systems solutions to retain and enhance its leading position in the industry. Designing and simulating automotive press tools is both an art and a science, and its success requires a perfect match of knowledge, expertise, and technology. Company founder, Peter Feltham, with over 20 years' experience in having trained at General Motors, understands the need for extreme accuracy, material controls, and process minimization. Peter explains, the rewards of this working methodology is very significant. The use of new materials and specialized steels in the automotive industry increases complexity. Hardness, resistance, and springback have to be accurately simulated and factored into the eventual design. Errors are potentially very costly. Peter goes on to tell us, the system's shape optimizer allows for accurate adjustment of compensation of springback, and because this can be seen graphically, customers can make better informed planning choices with a greater range of engineering options. It also reduces the number of tools and processes needed to press a panel and reduce 30% of the time and cost. And stated, CATIA is the key to developing and delivering optimized design intent. So in summary, we discussed 3 challenges and demonstrated how it's possible to address these challenges and dramatically reduce your product lead time. First, we saw how our efficient solution makes it easy and fast to transform a scanned mesh into a high-quality manufacturable model. 80% reduction in time taken is common. Next, we saw how to ensure quality and manufacturability by automating tooling compensation for part deformation, such as springback. Customers have seen this approach reduce overall tooling costs by 50%. Lastly, we demonstrated how you can quickly reconstruct and manufacture or optimize design with powerful tools, transforming a task that could take weeks into a simple and quick procedure. We hope you've enjoyed this short webinar and hope it gave you a good overview of scan to 3D print.